title, Fractals, the building blocks of the universe. Welcome to a journey into the heart of reality itself. Today, we embark on an exploration of one of the most profound and beautiful concepts in science, mathematics, and nature, fractals. These seemingly simple, yet infinitely complex structures are more than just mathematical curiosities. They are the fingerprints of the cosmos, the building blocks of our universe. From the spiraling arms of galaxies to the intricate branching of trees, from the veins in a leaf to the networks in our brains, fractals reveal the hidden order in the chaos around us. But what are fractals? And why are they so fundamental to our understanding of reality? Let's dive into the infinite world of fractals and discover their significance in shaping the universe. Section 1. What are fractals? Fractals are structures that exhibit self-similarity at different scales. This means that no matter how much you zoom in or out, you will find a similar pattern repeating itself. This concept was first formalized by the mathematician Benoit Mandelbrot in the 1970s, although the idea has roots that go back centuries, even appearing in art and nature long before it was understood scientifically. Imagine a simple line. You can draw it between 2 points, straight, predictable, finite. Now imagine instead a line that twists, turns, and doubles back on itself endlessly. As you zoom in on any segment of this line, rather than finding it smoothing out, you discover more twists, turns, and complexity. This is a fractal. One of the simplest and most famous fractals is the Koch snowflake. Start with an equilateral triangle, divide each side into 3, and then replace the middle segment with 2 sides of a smaller equilateral triangle. Repeat this process infinitely, and you create a shape with an infinite perimeter but finite area, a paradoxical, beautiful structure that exemplifies the essence of fractals. But fractals are not just mathematical oddities. They are everywhere in nature. Consider the branching of trees, the formation of clouds, the ruggedness of mountains, and even the patterns of our DNA. These natural phenomena follow fractal principles, where the same structures repeat at different scales, creating the complex and intricate world we live in. Section 2. The mathematics of fractals. To truly grasp the power of fractals, we need to delve into the mathematics behind them. At the core of fractals lies a simple idea: iteration. This is the process of repeating a set of instructions over and over again, each time using the output of the last step as the input for the next. This recursive process is what generates the infinite complexity we see in fractals. One of the most famous examples of a fractal is the Mandelbrot set, named after Benoit Mandelbrot himself. The Mandelbrot set is generated by iterating a simple equation. Z equals Z squared plus C, where Z and C are complex numbers. What makes the Mandelbrot set so fascinating is that within its boundary lies an infinite variety of shapes, forms, and patterns. As you zoom into the Mandelbrot set, you uncover endless layers of detail, each one more intricate and beautiful than the last. It's as if you are peering into the very fabric of the universe, revealing a hidden order that defies the imagination. The mathematics of fractals has profound implications not just for understanding nature, but also for fields as diverse as art, music, finance, and medicine. Fractal geometry has provided new ways to model complex systems, from stock markets to weather patterns, from the distribution of galaxies to the structure of the human brain. It challenges our traditional notions of dimensions and space, revealing that the universe is far more intricate and interconnected than we once believed. Section 3: Fractals in Nature. Nature is the grand artist of fractals. Everywhere we look, we find the signatures of fractal geometry in the natural world. The branching of trees and rivers, the spiral of shells and galaxies, the jagged contours of coastlines, and the turbulent flow of fluids. All these follow fractal patterns. It's as if nature itself is an artist, using the principles of fractals to craft the complexity and beauty we see around us. Take the simple leaf. Its veins branch out in a fractal pattern, ensuring that every part of the leaf receives nutrients efficiently. This same pattern is mirrored in the branching of trees, the formation of rivers, and even the structure of our lungs. The fractal design maximizes surface area, allowing for optimal exchange of gases and fluids. It's a design so efficient that evolution has adopted it repeatedly across different scales and species. Even the weather, with its chaotic and seemingly unpredictable behavior, follows fractal patterns. Clouds, lightning bolts, and even hurricanes exhibit fractal structures, where the same shapes repeat across different scales. This fractal nature allows meteorologists to model and predict weather patterns, even in the face of chaos. But perhaps the most profound example of fractals in nature is the universe itself. The distribution of galaxies, the structure of the cosmic web, and the formation of stars and planets all follow fractal principles. The universe is not just a random collection of matter and energy. It is a fractal, self-similar at different scales, with patterns that echo across the vastness of space and time. Section 4: Fractals and the Human Experience. Fractals are not just out there in the cosmos or in the natural world, they are within us as well. Our very minds, the way we think, and the way we perceive reality, are influenced by fractal patterns. The human brain, with its complex network of neurons, exhibits fractal characteristics. The way neurons branch and connect follows fractal geometry, allowing for the incredible complexity and flexibility of human thought. But the influence of fractals on the human experience goes beyond biology. Artists, musicians, and writers have long been inspired by fractals, even before the concept was formally defined. The repetition of themes, the use of symmetry and patterns, and the exploration of chaos and order, all these elements are rooted in fractal geometry. Whether it's the swirling forms in Van Gogh's Starry Night, the recursive structures in Bach's music, or the intricate patterns in Islamic art, fractals have shaped human creativity in profound ways. Even our sense of time and space may be influenced by fractal patterns. The rhythms of our lives, the cycles of nature, and the flow of history all exhibit fractal characteristics, where the same patterns repeat at different scales. It's as if our very existence is a fractal, with moments of clarity and chaos, order and disorder, repeating endlessly in the dance of life. Section 5, Fractals and the Future. As we look to the future, the study of fractals offers exciting possibilities for technology, science, and art. Fractals have already revolutionized fields like computer graphics, where they are used to create realistic landscapes and textures. But the potential of fractals goes far beyond that. In medicine, fractal geometry is being used to model complex biological systems, from the growth of tumors to the structure of blood vessels. By understanding the fractal nature of these systems, researchers can develop new treatments and therapies that are more effective and less invasive. In engineering, fractal designs are being used to create stronger and more efficient materials, from lightweight structures for space exploration to energy-efficient buildings that mimic the fractal patterns of nature. Fractals are also shaping the way we think about the environment and sustainability. By mimicking the fractal designs found in nature, architects and engineers are creating buildings and cities that are more in harmony with the natural world. These fractal-based designs not only reduce our environmental impact, but also create spaces that are more beautiful, functional, and inspiring. But perhaps the most exciting application of fractals is in the search for a unified theory of everything, a theory that can explain the fundamental forces and particles that make up the universe. Some physicists believe that fractals may hold the key to this ultimate theory, revealing the hidden connections between the quantum and cosmic scales. If this is true, then fractals are not just a mathematical curiosity. They are the very fabric of reality, the building blocks of the universe itself. Fractals are more than just shapes or patterns. They are a window into the infinite complexity of the universe. They reveal the hidden order in chaos, the beauty in randomness, and the interconnectedness of all things. From the smallest particle to the largest galaxy, fractals are the building blocks of our reality, shaping the world we see and the universe we inhabit. As we continue to explore the mysteries of fractals, we are not just uncovering mathematical truths, we are discovering the essence of existence itself. The study of fractals is a journey into the heart of reality, a journey that reveals the infinite possibilities of the universe and our place within it. So the next time you look at a tree, a cloud, or even your own reflection in the mirror, remember that you are seeing the work of fractals, the building blocks of the universe. And in understanding them, we begin to understand the cosmos itself. Thank you for joining us on this journey into the infinite. If you enjoyed this exploration, don't forget to like, share, and subscribe for more deep dives into the mysteries of the universe. Until next time, keep questioning, keep exploring, and keep marveling at the wonder of it all. This is the Philosopher's Canvas, where we explore the infinite possibilities of the universe, one concept at a time. Subscribe.